Welcome back to our 6-part series dealing with passwords. Last time we had a look at how passwords work online. We had looked at things like, are they stored in text, are they encrypted, are they hashed, and how that affects your password that you've selected. This time we'll have a look at how secure is your password. We'll deal with things like password entropy and how that factors in. Coming up after this, we'll deal with how to select a password, password examples, two-factor authentication, and whether or not you actually need password managers. So with that being said, let's jump right into part 2 of this series, How Secure is Your Password? In order to understand your password, we have to have a look at something that is called password entropy. In other words, how random a password is. The more random it is, the higher its entropy, and therefore the harder it is to crack that password with brute force or dictionary attacks. While password entropy doesn't really factor in when it comes to rainbow tables that hackers use, it does help to keep entropy in mind to make your password completely random. Once your password is random or uniquely random, it makes it highly unlikely that a hacker can either crack it or get into it using rainbow tables, because it's unlikely that that password will be in any rainbow table on the internet. The formula for password entropy is expressed as E equals log base 2 R multiplied by L, where E is entropy expressed in bits because we're dealing with computers. Log base 2 is a binary algorithm of the number of characters in a character set, which is what R is, and then you multiply that by the length of the password. Okay, let's break this down as a table. In the table, we're going to have the pool that we're drawing from, the number of elements in that pool, the pool size or the character set, and then we'll have a look at the actual log base 2 of the character set. So first up we have numbers, which gives us 0 through 9, or a pool size of 10, or a character set of 10. Next up we have lowercase letters, A through Z, which is 26. Then we have uppercase letters, A through Z, which is also 26. Now if we have a look at uppercase and lowercase letters, we have 52 characters in the pool set. Lowercase and numbers, we have 36. If we look at alphanumeric, which is A through Z, uppercase and lowercase, and numbers 0 through 9, we have 62 characters in that set. Now if we take special characters, and on your typical keyboard you do have a spacebar. So if we account for the spacebar as well, we have a pool size of 33. Then if we take everything from our keyboard, a normal keyboard that you would have, you get a pool size or a character set of 95 characters. Then there's another option, which is what I would recommend, and we'll get into this in more detail in a bit, and it's called the Diceware word list. That has a pool size of 7,776. In order to see this in a real-world example of where this comes into effect, let's first save ourselves some time, and we'll take our number of characters that we have in the table, and we'll convert them to the binary logarithm or the log base 2 values. And that we use the natural logarithm value of the keyboard. So if we click on Start and type in calc, and when you see it pop up in the list here, just hit enter, and that brings up the calculator on the screen. Okay, so with the calculator open, we're first going to switch it from standard to scientific. So click on the 3 lines at the top here, change it to scientific, and this is the calculator that we're going to be dealing with. If we're dealing with digits, where you've got a 10-digit pool size, to convert that to the log base 2 value, all we have to do is type in 10, and the ln on the keyboard here, which is a natural logarithm. But because it is base 2, we have to then divide that by 2, or the natural logarithm of 2, and that gives us our actual value of 3.322 if we round it up. And same thing basically if we clear that off now, and we go 26 ln divided by 2, and 26 gives us 4.700. And we'll just go down the table quickly. I'll fill in the rest of the values. Okay, why is this so important? Well, if we calculate the entropy of a particular password, let's say, for example, we know that the entropy, if you're using A through Z, lowercase, or just uppercase, we know that the value is 4.7 for the log base 2. We multiply that by the number of characters in your password. So say you chose a password of 8 characters in length. your entropy value is 37.6 bits, which honestly speaking is really, really low. You want to be trying to aim for an entropy of at least 64 or higher. Now, a couple of ways to get there. First thing is we'll try a different pool size. So let's try the entire set. We know that the log base 2 value of the entire keyboard set is 6.57. And we multiply that by 8 is in the number of characters that you're choosing, and you get an entropy of 52.56. That is still not quite high enough. So the only way you can increase that is to increase the number of characters or the length of your password. Again, we'll look at 6.57, and this is why banks always say, no, you must have an uppercase, a lowercase, a number, and a character in your password, because then you're using the full 6.57 log base 2 value of the character set. So if we do this, multiply by, say, we now change our password to 12 characters, we get 78.84. Definitely higher than the 64, but the ideal is around about 80. That's what you want to be aiming for. So you'd be looking at a password of about 13 characters in length or higher if you really want to be protected completely from hackers. If you want to start applying this to some real-world practical examples, let's have a look at something here. If we have a look at our password pool, say, for example, we're only using digits 0 through 9. So that gives us a pool of 10. If you have a password of, say, 8 characters in length, what you would do is use exponents. So the base is 10, and if you've got the character or the password is 8 characters in length, you've got basically 100 million possible password combinations just using 0 through 9. Okay, let's clear off our calculator here. Now, let's look at the average person who uses, say, uppercase and lowercase letters in the alphabet. That gives us a combination of 52. So 52 is our base. A normal person would use approximately 8 characters in their password. So there is your number of password combinations for an 8-character password using uppercase, lowercase letters of the alphabet. A decent computer with an okay video card is going to crack this in, let's see how long. The average computer does about 100 billion passwords per second. So we divide it by 1 with 11 zeros behind it. That gives us 100 billion. That's how many seconds it's going to take to crack that password. We divide that by 60 to give us minutes. So 8.9 minutes to crack that password if it's a brute force attempt. So we'll clear this off again, and we'll deal with our previous example where we dealt with the entire character set of 95 and a password length of 12. That is now the number of possible password combinations for your password. And if you divide that by the 100 billion to see how long it's going to take to crack that, that is in seconds how long it's going to take. So divide seconds by 60 to give us minutes. There's the number of minutes. Divide by 60 again to give us hours. There's the number of hours. And divide by 24 to give us days. Divide by 365 to give us years. So as you can see, it's still 171,000 years to brute force crack that particular password. But bear in mind, earlier I had mentioned passwords are not just about hacking or cracking. It's also about dictionary attacks, because many websites store the passwords as hash tables. That is why your password needs to be unique, so that your hash has never been used by any other user ever. So choosing a password that's unique is critical to making sure that it can never be cracked. Okay, now that we've cleared off our screen, let's have a look at a couple of things here. What I want to do is just show you a couple of websites that you can go to check your password to see how secure it is or if you've been hacked. So let's start off with our websites here. I've put them all up in the top just to save some time typing them in. The first one I want to show you is a site that shows you how secure your password is. So you can actually test the strength of your password. And what I'm going to do is I'm going to use the same password throughout this whole experience, which is password with an uppercase P. Then I'm going to use the @ symbol instead of A, then SSW0RD. So we've used all the different groups in terms of characters. So we're using the full 95 character set for our password. And if you have a look on the screen here, it tells you that it's going to take a brute force hack about 8 hours to crack this password. This is where the issue comes in. Most of the common passwords are all kept together. So let's go forward, and I'll show you what I'm getting at in a second here. There's another site here called Have I Been Pwned, or it's just a derivative of Have I Been Owned. And you can type in your email address here. Say, for example, we type in support@microsoft.com, but obviously you'd want to type your own address to check it. So if you check it, you can see that this particular email address has been owned in 66 different data breaches, and it will give you all the breaches at the bottom here that it's been compromised in. Now that doesn't necessarily mean they've got the password, but they do have the password hash. So that is somewhere in a database online. So that's one site to keep in mind. The next one is a hash generator. So whatever your password is, say we're going to create the same password, so p@SSW0RD. And we go to generate this, and we're generating it in as SHA-1 right now. There's the actual password hash for SHA-1. And what you can do, if you've got this point, is copy this hash here, and we'll go on to our next one, which is hash tables. What we can do is paste this hash into the hash table, and you can see right away, immediately, it finds the password. And that's what the password is. So this would not have taken 8 hours, as you can see. It's because this particular hash is already in a rainbow table online that hackers can gain access to pretty quick. And you'll be surprised how many people use the same password for so many different things. It's actually pretty scary when you really get into it. There's also another site here that I use quite a bit too, which is this one here, Password Range. If you know what the hash is, which we've just checked on this site right here. So let me just go back to that site here a second. Okay, so we've got our password hash. Now, if you have a look, the site that I'm going to right now, we're going to look at the first 5 characters of the password. We'll copy that out there, and we'll go into our hash range. All we have to do at the end of this line here is put the first 5 characters, D1, and there's all the hashes that this picked up immediately with a password hash beginning in 21BD1. And if we scroll down the list here, I can tell you right away, you can see that's the actual hash right there. And if you compare that to this ending in 72A757, 72A7, so you can see this hash is identical. And it shows you that this particular one has been breached 57,368 times. You can see that's definitely not a unique password. A lot of people are using it, and that's where part of this problem comes into. Now, because we've used this password online, I would recommend changing it right away. Because what some of these websites do is every time you go to check your password, it's adding those to their own hash tables. And of course, they're going to sell it in the background. That's what it's all about, is finding these unique passwords that they can hash. If you don't want to do that, click on Start, go into Windows Terminal, and we're going to run a Ubuntu session, which I showed you in my previous video. Just give Ubuntu a second to load here. And the particular command that we want to type in, echo -n, and we're going to use the same password. So instead of going online to check a password and potentially compromising your password and putting it into an existing hash table, use an Ubuntu command line, which you can now do in Windows or with the new Windows Terminal session. And we're going to pipe that to SHA-1 sum. And there we go. There's the password hash that we've just obtained, which is identical to what this is. So if you're worried about checking online if you've been compromised, you can do it in an Ubuntu session. But how do you check if that password or if that hash has actually been compromised online? Enter in the command curl. We can use curl and the exact same website name. So let me just copy the link here. So there's the same website name. And we take the first 5 characters of our hash, paste it in there, and see, this is basically done exactly what we would have done online, except you're doing it away from the server so they're not getting the information from you. And it's the exact same list because you can see 57,368 times that particular hash has been used online. So check your passwords, make sure they're secure. Don't ever create a password that you think is unique, because it most likely is not unique. I did mention earlier in this video something called diceware. And that is something that I would recommend. But please keep that in mind, because in the next video that I'm going to do in a couple of days, I'm going to detail how to select a password. And one of the options for selecting a password that is easy to remember but really tough to crack, or with hash tables that don't exist for that particular password, is using diceware. So until next time, folks, have yourselves a fantastic day. Take care. Bye for now.